Hello and welcome back to AVR 6R2. This is tutorial number 4, which goes over chapter 5, which is animation, physics, and colliders. So in order to have an immersive experience, we need to be able to understand all of these three things that determine how objects are going to move in our scene when we interact with them. We're going to learn how to use rigid bodies, which is a component that allows an object to have physics, to move around, experience gravity, colliding with objects, which includes things like colliders. We'll understand how to record and create clips of animation, such that when we use interactors like gaze or raycast, it'll cause objects to play their animation. So in this chapter, we'll be looking at Unity's physics system in particular and implementing that into the animation, along with components that we can add to our VR objects and our VR rig to give it more of a realistic feeling. One of those is the rigid body, which I may have already mentioned. So for example, if I click on my Sphere Multi Tomato, it should have a rigid body, which was added when I believe I gave it the grab interactable, because that will allow the object to move around, experience gravity. So again, what is a rigid body and what is a collider? So the rigid body is a component that allows it to obey the rules described by Unity's physics engine. You can add physics-based interactions to your VR objects. You can throw them, you can have them bounce off walls and move around. Attaching the collider, the sphere collider, will determine what the object's shape is, not in terms of what you may see, because obviously the tomato isn't completely spherical, but in terms of how Unity computes its collisions as it bounces, it would act as if it were a sphere. So these 3D objects have relatively simple meshes, but if you were to use more complicated objects, I would not recommend using its mesh collider, because these objects do have a mesh collider. So if I were to make an empty scene, I'll show you real quick. Let's say I made that torus from ProBuilder and brought it over to the center. This actually uses a mesh collider. So the mesh collider matches the 3D mesh, the 3D shape of this object. I can give it a material if I want to. And this is a bit more complicated of a shape than what we're used to seeing, because if I wanted to add a component, most of the colliders, there's box collider, there's capsule collider, there's some 2D colliders, which we're not able to use in Unity 3D. But let's say I wanted to use a box collider, then I would fit the box around it, and it would move around as if it were a box, which obviously is not very accurate. But the sacrifice I make by using, say, the mesh collider is that's going to up the amount of work that Unity has to do to process all of these collisions, which may lead to drops in frame rate, trouble processing on, say, lower performance devices. That's why back in our previous scene, we were better off just approximating this to be a cube and using a box collider for it. So if I just have the cube in like play mode, for example, the cube here, it's not going to be moving at all because it doesn't have a rigid body. So let's say I added a rigid body to it. Now it just moved. It experiences gravity. So if I let go, it'll fall. It might rotate and fall over. I can toggle using gravity, for example, and it actually won't fall. Also, if I use is kinematic, it doesn't move. Interpolation. So inter meaning like between frames. This allows smoothing between the like different frames of where it would be. It essentially makes it a bit more precise in terms of how its motion is calculated. Let's say if you want your material to be more bouncy or have friction, you can assign it a physics material, which is under its collider. So let's say I want the floor to be more bouncy, for example. I could go to create, click physics material down here. So I have a new physics material and I can call it like floor. This dynamic friction, static friction, bounciness. And so this actually computes all of that for me without, say, having to write a complicated script in which I compute how high something will bounce, etc. I give it like a floor material, and then I allow gravity on this again. Let's say that I make this super duper bouncy. Well, I don't know what happens if I put it above 1. Maybe that makes it go faster than it's going when I hit it. Turn this off. And you can see it bounces now. So that's a way that you can add some more realism when it comes to those physical objects and how they interact. We'll also talk about raycasting, which is using the physics engine to allow you to detect where an intersection will be from the user's controllers and a collider containing objects in our scene. So this will be useful for grabbing and throwing objects. We'll also talk about, again, the animation system, using the animation window, setting up keyframes, which are important locations for all of the joints or objects to be during an animation. And we'll get into all that in depth during this lesson. Now, we talked about the rigid body component a little bit already. So again, the mass will determine how strongly it responds to forces and collisions. So if it has a bigger mass, it's going to be harder to push or pull it away. Drag is how much it'll slow down while traveling in the air or in general. This angular drag is kind of its resistance to rotation, so if it's spinning, it'll slow down spinning over time. Again, you can choose to have it be influenced by gravity, and is kinetic will actually stop it from moving. So with the interpolation I mentioned, which smooths out the motion of a rigid body, you can choose interpolate, which interpolates the motion of the rigid body between updates. So that will prevent it from looking a bit jittery. Sorry, you can also use extrapolate, which kind of, if you've heard of extrapolation, it's almost like making a prediction. That will be useful if the physics engine is running slower than the frame rate at which the game renders. Then you also have collision detection, which is going to be obviously used when you have collisions between objects. Discrete is default. It just checks for collisions at the end of each update. So once two objects are touching at a frame, they're like, okay, we're going to initiate the collision now. But if I choose to do continuous, for example, this checks for collisions continuously during the update, which can be more accurate, but it can also be more computationally expensive. So, but it's good when you're using fast objects, because it'll allow it will predict where the object will be in the next frame, so it won't cause any overlap between the two objects. You also have continuous dynamic, which is even more accurate than discrete mode and efficient than continuous mode. So it's designed for fast moving, and you have high frequency motion. And lastly, you have some of your constraints. So if you want to freeze it along X, Y, or Z, let's say I don't want this block coming off the ground, I can freeze it in the Y, or I don't want it rotating, I can freeze it in one of these said directions as well. So it is able to still collide, but it's immune to being rotated or moved, translated in any of these directions that you so choose. So we're going to make a whole new set of scenes for Chapter 5. And we're going to go to create scene and call this one 5_01_ rigid body collider. Oh, sorry, rigid body and collider. You're going to open it. We could save what we just did in our sample scene, that's fine. But we should be welcomed with nothing here. We should have made a demo room prefab from our last demonstration. So it looks like we already made the demo room parent object, which has all these objects with the table and stuff, all the sockets, and our actual rendered room mesh. So we can make this a prefab by going to our prefabs folder and then just dragging this in. So now it's been made as a prefab, and you can see it's highlighted in blue. Let me go back to our new scene. Okay, here. Don't save. We can go to prefabs. Sorry. There, our demo room, we could drag this in. So now we have this already here. We can also drag in our teleport floor if we want. And then we also need our VR rig. So we essentially brought in everything we needed. If we had earlier, I should say. If you didn't want to have the teleport floor, which includes the table, I don't know if I should have done that, but everything is still here. And we're going to delete the main camera because we only needed the one from VR rig. We can delete this main camera up here. We're going to make what's called an event. So we're going to right click and choose UI and go to event system, which is down at the bottom. Yeah, it's already set up at the origin, fortunately. In this event, we're going to click replace input system UI, this whole thing, replace with input system UI module. So now that we've created this, we're going to add a rigid body to our VR rig because it doesn't have one. So this is, again, this is essentially the player. So we're going to give it a rigid body, and we're going to freeze its rotation so that the player cannot rotate. Obviously, the player should be able to move, like translate. You may be wondering, well, we're supposed to be able to rotate, right? We're supposed to be able to turn as we look around and use locomotion. Yes. This prevents rotation from any kind of collisions that are happening. So if we bump into an object, it won't cause us to rotate, which would definitely produce some motion sickness for our user. And what we're going to do with this later is we're going to add a collider so we can't just walk through tables and things like that, because that would be a bit unrealistic. So we talked a bit about colliders already. When they come into contact with each other, the Unity engine will calculate the collision and apply the appropriate forces for us, and that's called collision resolution. The physics engine uses the properties of colliders like mass, the collision material, how bouncy it is, and determine how the object should react after the collision. And we talked about some of the basic shapes. There's box collider, sphere collider, capsule, mesh, and terrain collider. And we need to pick the one that is most appropriate for our object. So what we're going to do is take the XR origin game object that we have here already. I don't really like this idea. For some reason, it wants us to make a capsule and copy its collider only onto the game object player. But I think what would be faster is not doing that. But, well, we can go to the XR rig object itself and add a component and just click capsule collider, because it already gives us a preview of what it will look like. It's a little bit under, and I can't move it like this because that'll move the entire game object. I actually have to go in here where it says center and raise it up. And let's give it a height of 2 and a radius of 0.5. So now this would be our player collider. So we're not going to be able to just walk through tables like I mentioned earlier, or walls and things like that, because this whole building has its own wall collider, so we won't be able to walk through the walls like earlier. So notice that if I try to walk through now, I get blocked off. I literally cannot get any closer to the table than the collider lets me. So also I won't be able to walk through the wall. So if I want to change how close I can get, because obviously this isn't like point blank, my face is touching the wall, then I can decrease that radius value that I have. So if I want to actually tinker with this while I'm in play mode, remember you can. Play mode is useful for that. If I want to try different values to mess around with, let's say I made the radius instead of 0.5, I make it 0.2. So that should allow me to get a bit closer to the wall in play mode than I was earlier. So I'm about to get a bit closer, but only a limited amount. And so yeah, all these changes you make in play mode, remember they don't, they go away once you exit play mode, so you'll have to remember to implement afterwards. Yeah, I never really tried to just walk through the wall like that, because why would I decide to do that? There you go. I fell out of the world. So if I didn't have this collider, I'm just walk right through the wall and exit the room, which we probably don't want our player doing that. All right, so now that we know how to add a collider to our VR rig, we should probably edit our prefab and make a variant of this. I don't remember why we made this other prefab variant. I'm just gonna delete it. But I'm gonna make a variant of this prefab variant, and then I'm gonna name it as VR rig physics variant. And so I have it open here, and I can give it that same capsule collider with the same dimensions that I did earlier. Let's see, what I can do is I can right click, do copy component, go into my prefab editor, and then right click and choose paste component values, and it'll paste those coordinates and radius, all that stuff that I just added. So now I can save it, exit out, and now I'll have this prefab for the VR rig with the collider included if I wanted to have physics. So we were able to determine the dimensions of our collider, but now what we should do is add some numbers that reflect human-like behavior in a physics-based VR environment. So we can tune our rigid body to match what that would be like. We should set the mass somewhere between 70 to 85 kilograms. Let's just go with 80 then, for an average adult human being. The drag should be somewhere between 0.1 and 0.2, so we at least have some drag. Let's set it to 0.2 since we chose the heavier side of the mass. The interpolation should be set to interpolate or extrapolate. I have a relatively decent performing computer, so I'll choose interpolate. The collision detection should be either continuous or continuous dynamic. I'll just click continuous. And then the angular drag should be somewhere between 0.05 and 0.1, which it already is. I'll just leave it. It's important to note that the best settings for simulating human-like behavior will depend on the specific requirements for your project. So you may need to tune these later on, including the shape, size, properties, etc., based on your playtesting. And then if you actually wanted to make these changes to our VRReg physics prefab, I realized I didn't add a rigid body to this, so let's go ahead and add that rigid body. And I copied the parameters from the one in the scene, so I could just paste component values, and now I have all of these set up. Control S to save my prefab now. The book later talks about creating barriers like walls and things. Like you just can create a box or a sphere, and each of those can collide. And you can test the barrier by, say, walking into it and tweak the settings as necessary. But we don't really need to do that. We already have this table which has its own box colliders. So this has a box collider, this has a box collider. We already tested the wall that has a mesh collider. The actual room has a mesh collider along all of its walls. And we demonstrated that if we try walking into the wall, it just stops us, so we don't need to make any changes to that either. So now that we've got physics and collision set up, I want to talk about introducing Unity's animation system. So like how we have a scene window, inspector window, there's actually an animation window, which will allow us to create and edit and preview different animation clips so that we can tune them to look the way that we'd like. There's also an animating component, there's an animator, and there's animation. So there's an animator that kind of manages what animation will play when based on certain parameters for a game object. You'll also have the animation itself, which is a clip based on some pre-recorded value or values that you set, whether that be for a bone on a 3D rig if you had some kind of character, or you can just simply edit its transform, its scale, its position, its rotation, etc. You also have animation events, which are events that may trigger an animation using C# scripting, and you also have humanoid or generic animation rigs. As I mentioned with a rig, it contains all the bones like arms, legs, fingers that you can set the individual positions for and implement keyframes for. We're also going to talk about Unity timelines. So as the name suggests, the timeline allows you to create a series of events, like assigning animation, audio, camera movements to be played at specific points in time. So with the timeline, you can create complex and dynamic sequences like a cutscene or some kind of viewable sequence that you can create with interactable sequences and controlling tracks on the timeline. So some of the main features for that is visual editing. It actually has a user interface for creating and editing timelines, which makes it easier to make complex sequences. You have multi-track support, playback control, timeline control tracks. It's easily customizable, and you have a timeline asset that allows you to save and reuse timelines across different scenes and projects. So let's go ahead and make a new scene where we can experiment with this feature. As per usual, I'm going to go into my scenes folder, go to chapter 5, save this and make a duplicate, rename it as 5_02_ timeline. So what we're going to do here is we're going to make a couple of doors and animate them. So we'll create 2 empty game objects. So you create empty, call it door 1. Oh, sorry, not door 1. We'll call one of them left door. And then make sure it's at 0, 0, 0. The other object, we can make a duplicate of this and then rename it as right door. Actually, it looks like, according to the book, they set these locations for the doors at specific locations. Because the demo room itself should be at 0, 0, 0, which it is. This whole demo room is at that fixed location. You can set the left door. We're actually going to put it at -6.2. -6.2. Height 0. Height, or Z, -0.084. So now this actually aligns with this hallway approximately. If you remember when I made the Google drawing, it didn't line up perfectly, so we can change that later. And the right door is at position 6.540, because they're the same Y height, -1.31. Do that right? Yep, okay. The other door should be at the other hallway. I have to focus. Now they're going to use a cube as a child for each door. So I'm going to create a 3D object that is a cube, duplicate it, drag it into both of these. Not sure if we need to give it a name yet. Oh, yeah. So we made the cube. We got to set the origin to 0, 0, 0. Same for this one. Put it at 0, 0, 0. You drag it into the left door and the right door. If you notice, I actually want the cube to line up with the door, which is over here. We should actually change its transform to the origin after making it a child such that it lines up properly. Same thing for this one. Make it 0, 0, 0 after we've dragged it onto its parent object. Now they want us to raise the cubes because obviously we don't want them in the ground. We're going to raise it to 2.084 for the Y. Obviously, these aren't sized as doors yet either. We're gonna set the scale of these doors to 3 by 3 by 4 to make it align properly. I think the book meant to have it scaled at 3 in the X, 4 in the Y, because remember when we did the extrusion, we set it to 4 blocks tall, and then 3. So let's do that for this one. 3, 4, 3. That looks better. So now we're gonna add custom animations to both of these what would be doors. And again, we'll see how it lines up after we make the animation, because I'm not sure if this hinges open or this slides or how this is gonna, or if it slides or how this is gonna work. So if I go into the editor and go to the window panel and click on sequencing and go to timeline, I can access the timeline panel, which I'm gonna drag this down here so I can still see my scene. And I'm going to create an empty object in the hierarchy, and I'm going to call it demo animations timeline. I'm also going to make an animations folder, because remember, for every asset type, it's good practice to create a folder to organize them, so I'll call it animations. Open this. There should be nothing here yet, but when I select this demo animations timeline, it says, begin a new timeline with this, create a director component and a timeline asset. So when I hit create, that'll do that for me. Looks like I'm gonna need to save it somewhere. This is already saved under my project name, so it's demo animations timeline. Click save. So now it's got this timeline set up with this play button. It's got ripple mode, replace mode, all these different modes, along with the amount of frames or seconds, depending on what this scale is for. So we've saved it in the animations folder, and in the inspector for this, for the demo animations timeline, we're gonna make sure we set the update method. We're gonna change the wrap mode to loop, and we're gonna make sure that the play on awake option is on, so that it'll start playing the animation right away. Now in this timeline panel or window, we're gonna go to the settings. There's a little cogwheel or gear in the top right, and we're gonna make sure that we change the frame rate down here to 24 frames per second. Then I can see that my scale up here changed. Also, what may be kind of annoying is if we go and click on other game objects and things like that, it changes this. We're gonna click the little lock down here so that we keep this window as we click on other game objects. So now that we have our timeline window set, we can start making an animation for the left and right doors opening and closing. I'll select the right door game object, this object over here. So we'll start with this one first. Because when I drag right door down here, I need to click add animation track, and now there's this little recording button that will show up. So I'm going to select it so that it's now recording, and I'm currently on frame 0. And so what's going to happen is it's going to transition between all of the keyframes that I choose, and you'll see how that works as I do this example. So for frame 0, I'm going to set the initial frame with this animation by adding a key for the position of the transform. So in the inspector, so if I go to the right door's transform, there's an option to add key. So I'll right click and click add key. And then I can also do this for the rotation. So I will right click here and click add key. So if you look here, it adds this little diamond right here showing that this is a keyframe. So in the animation tab, it's captured both our rotation and position at this moment to be the beginning of our animation. So it's going to start closed. I assume this is closed, so I might have to move the entire thing depending on how it works, because the way that I set up our room. I want this to be a bit closer to 5 seconds. There. So if I click on the cogwheel and show seconds, it'll show me how long each second is. This is only half a second. Because remember, it's 24 frames per second. So 5 seconds would be 5 times 24. So I'm going to go to the 5 second mark on the timeline, and I'm going to create the same keys I did earlier. I'm going to right click on the position, use add key, right click on the rotation, click add key. Now I have another keyframe at 5 seconds. So it's going to be closed for the first 5 seconds, and then when it hits 7 seconds, it's going to open. We need to create animation keys that'll open the door. At this moment, 7 seconds later, it'll be 90 on the Y, and I'm going to move it to -3 on the Z axis for the position, like that. So you have to be careful. Sometimes this may turn off. You need to make sure it's still in recording mode. So I'm gonna, I don't need to right click. Oh, I do need to right click, add key. So I'm at 7 seconds, I'm gonna have the door open. I'm gonna adjust its rotation to 90 and set its Z to -3. And I'm going to add these as keys. It looks like if you change that number, it actually updates it automatically for you. So that's pretty convenient. I'm gonna have this door stay open until the 15-second mark. And so remember that if I change these values, it adds a key there automatically. But if I don't make any changes and I want it to stay at this position, I'm gonna need to add those keys manually. And then at 17 seconds, I want it to close again. So once I'm at 17 seconds, I'm going to set its Y rotation back to 0 and set its Z to -1.3. And then I can deselect this record button to stop recording. So it started closed for a while, and then from 5 to seconds, it turns open like this. It stays there for a while, and then it will close back again. These keyframes determine, okay, it should be here at this point, here at this point, here at this point. And so Unity realizes this, and it fills in the transition in between to uniformly rotate the object from one keyframe to another. So I can actually go to the beginning and press the space bar to hit play, or just hit play here, and I can watch it play the animation. This is what it would look like in real time when it opens and closes. Now that we're done with this, we can do the same process for the left door. So let's go over here, look at our other door. From what I saw in the animation, it looks like it kind of opens as a hinge. Now I can keep this as the same for my timeline, especially if I want the doors to open in sync. So I can take the left door object and drag that in here and add another animation track. I'm going to press record here. And so again, I'll go through the same process. So I'll take its default position rotation, add that as a key, default position rotation, add that as a key. Go to 5 seconds. That's how long I want it to stay open for. I'll add it as a key again. Add a key, add a key. Go to 7 seconds. This one, I'm going to have the door lift up instead. I'm going to set the Y position to 3.5. Sorry, position, not rotation, 3.5. You see that created a new keyframe for us because I changed these values. Then I go to 15 seconds. I'm going to add the keyframes because I want it to stay there for that long. I'll add the key for just the position. I guess the rotation doesn't matter. And then I'm going to have it return to its original position at 17 seconds by setting the Y back to 0. Now I can preview this, turn off my recording, press the space bar. That will allow the animation to play. So this one is going to open up for us vertically and then come back down. Both of these, I believe, will happen in unison, the way that I've got these set up. Let me go back to the beginning. So now I know that my door is going to open kind of around this corner. So what I'm going to do is I'm going to take the left door object and move it to where it should be. See if I could find where its center is right here. Sorry, the right door. Line it up so that it goes with the floor. I can actually use the vertex snapping feature. So if I hold on to V, I can select this and drag it, let go, and it'll actually snap to the corner of my my floor mesh that I made, or my wall. So click V and then let go. Now they'll snap to where I want them to be in the wall. And so the animation was based on the left door and right door parent object, but not on the cube mesh. This is how they'll both open and close together. So we have our animation for the doors. When you press play, the whole animation takes about 17 seconds is what we set it to. And so yeah, we might want to tweak these animation clips after they're completed. So you can just, if you wanted to make these edits, let me pause this again. Yeah, so if you wanted to edit these animations, you can click on these little purple diamonds, and these will allow you to change the position that it's holding at this time. If I go here, maybe I want it actually over here. Like I want it to rotate like that. If you actually wanted to apply it, which I wouldn't, that would kind of mess up everything. You can also drag these. Maybe I want it to, this is how long it's supposed to hold for. Maybe I want it to hold closed for a short amount of time and then open very slowly so that it'll do that. So you can drag around when these keyframes happen and actually edit the keyframes themselves. So now that our animations are complete, we can save those sequences as animation clips that can be reused in other timelines. So if you want to save these as animations, so for example, on the right door, I can choose the 3 vertical dots right here, and it'll open up the animation tracks options menu. I can select convert to clip track. So now this is this whole recorded thing. I can drag this and choose when this recorded clip will happen. I can do the same thing with this one, convert to clip track. I can change the name of this up here. So let's call this right door. And I call this one left door. You can also change the blend curves here, which influences how quickly it transitions between the keyframes. So maybe you want it to linearly do it, or it speeds up in between. You can change all of those in here. So you can mess with these, and maybe I want to change the speed of this. I want to make it like 4 times as fast. I could do that if I wanted to. So hit play. Now it'll open and close very quickly. But I don't think we want a door that's gonna like smack our player around by moving so fast that they can't keep up with it. Oh, I shouldn't have said that. And so now in our assets under animations, we have this timeline, and we have both of these animations that are already saved. So if I want to save this as its own thing, I can copy and paste these animations for for doors 1 and 2. So now that we have these animations pre-made, we can say make an event that causes the animation to happen. So maybe this is some kind of puzzle room and the player enters a code correctly. They find some kind of hidden object that allows them to open a door to advance to the next room. We can make that happen. And we can do that using animation triggers. And what we're going to do is create this in a new scene. We're going to go to our scenes folder, chapter 5, save this, make a duplicate, and rename it as 5_03_ animation trigger. We're going to make an empty game object in our hierarchy, and we're going to call it ray animation trigger. We're going to place a cube on the wall, and it's going to act as a trigger. We're going to make like a ray animation, or we're going to make a ray interactor that will have a cube object, like a button we can press. We're going to call this ray animation trigger, this game object. And what I'm going to do is I'm going to drag it over here and put it up by the wall. Let's make it a little bit smaller, like 0.5. Okay. Drag it into the wall so it's a bit flatter. We have this button here. Maybe we could give it a material, whatever color we want to make it. Let's make something that stands out from the wall. So let's use like an orange. And then we're going to add an XR interactable component to this. So we'll click add a component, XR interactable. Among the ones that we've already used, I want to make it a direct interactor so we could just walk up and touch it, and then it will press that button. It says it needs an XR controller, which we should already have. You drag XR interaction manager in here. So remember that when we set up these interactables, we had interactor events. Let's say that once we actually select the object or like click on it, we can add an event that we want to trigger, which will be this. We're going to create an empty game object again and call it right door open timeline. Or we call it right door open timeline. And create a new animation timeline asset in the timeline window for it. So we'll click create. And this should be in our animations folder. Click save. Now remember, if you remember, I already have my demo animations timeline right here. And so when I open this, let me turn off the lock. I have this right door animation. I am going to copy that into here. What is going on? Why are you over here? Okay, don't know why that happened. But so I've copied it into here. I've copied it into here. And then I'm gonna hit play. Double check that it still works. It should open at around 5 seconds. There we go. Now, I want to start this animation a bit sooner than what we recorded at. I don't want to press the button and then have the player waiting for 5 seconds because they're going to wonder if something's wrong. So I can go to, let's say, around 3.5 seconds, press S, and that will split it. So now it's going to start at this point. When I drag it here, it's going to start a bit sooner. So we'll only have to wait a bit longer. So we won't have to wait as long. Let's see what happens if I do this. I drag it from the left. Yeah, you can also do that too. Like, you can drag this so that it also triggers it a bit earlier. So now we have a playable director component for this timeline. So for this right door open timeline, it has a playable director that determines what causes the animation to happen, when it's going to happen, etc. We set the wrap mode to none. We don't want this looping, so good, it's already set to that. And we're going to turn off play on wake because we don't want this animation to happen immediately. We want this animation to happen once we, say, interact with this button. So in order to trigger this to happen, we're going to go back to our ray animation trigger object, this little cube guy, and we're going to go to the interactable events, which we had set down here. And we're going to go to the select entered event, like I mentioned earlier. This is once we tap on it. And I'm going to drag the right door open timeline game object to the event slot here. And then the function is going to be playable director, and then we're going to choose playable director play. So I have playable director.play in the slot. So this is going to play the animation when the event happens. If you remember earlier, if you remember from the second tutorial, we made it so that it changes materials for the object we were interacting with. But instead, we're making the animation play for a different object using its animation director object. Maybe we want the object to turn green when we hover over it. So that tells the player, hey, this is a special interactable object. And then when they actually click on it, it'll trigger the animation. And remember that when we change the material, we also want to make sure that it goes back to its original color when we exit these. So when I let go or when I exit my select, that will also bring it back to its original color. So let's do that for select exited, and let's also do that for hover exited. Go to mesh render material. And so for both of these, I'm going to drag in the orange material that I gave this. Okay, now let's go ahead and test this. All right, I'm going to see if I can interact with that now. Well, for some reason, it's opening automatically. I should probably turn off this play on wake for the demo animations, or else it's going to play these by default now. Let me double check that this has the trigger on. This should probably have an interaction layer mask of objects, since we're usually going to be interacting with objects as well. So one of my mistakes was that I gave this the interactor component when the interactor is supposed to be my left hand. Because remember, this is the interactable, this is the interactor. The left hand is the one that does the interacting. All right, so since this is an interactable object, I'm going to, let's give it a simple interactable. Make sure that we drag in the XR interaction manager over here as its interaction manager. You don't need a custom reticle or any of that stuff. So what we'll do is, when I go to hover, I'm going to add the object under here, and then go to mesh renderer material, and then drag the green material in here. So it'll turn green once I hover over this object. So it's called when an interactor begins hovering. When it exits, I want to change it back to its original color. Mesh renderer material, and that original orange. And then when I actually select and click on it, I'm going to have that actually trigger this right door open timeline. Then I'll choose playable director and choose play. Maybe I want like another, maybe I want the cube to change another color just to make sure that I did this properly. So let's make it choose pink, like the active color. Oh, I'm sorry, make sure you drag the object in there. Mesh render material, pink. You know, let's see what happens, see if this works now. So for some reason I can't seem to interact with my left hand, but when I put my ray on it, that is actually able to interact. So it turns green when I hover, and then when I click, it turns pink, and that will trigger the door to open. That might have been because the right controller has an interaction mask on everything, and the left controller interaction mask I set to object. And this object here's interaction is set to default. Maybe what I should do is change it to object. Okay, so when I come over here and I bring my left hand, it is now interactable. So I hover and leave, and it goes back to the original color. I click, and I'm able to open it with my left hand as well. Maybe you might want to lower the button a little bit because it hurt. But yeah, those are some things that you can tune. So this is great. We are able to trigger animations using the interactors that we went over in Chapter 3. That also includes using the gaze interactor. So we could also trigger this animation using gaze interactor. So in order to do that, we'll go through the following steps. We'll go to this object, shrink this, and we can also add a gaze interactable. So we have to choose is activable, and we're going to have to set all of these. So let's say that on gaze enter, we will make it that green color. So this is good practice for setting up all of our interactables. I know that was a while ago. On gaze exit, we're going to use the same original material now. So let's go to our materials and set that up. So when you enter the gaze, you'll use this. When when I stop looking at it, let's go to mesh render material and give it the original. And then once it's activated, that's when my door is going to open. Let's go ahead. But in order to make sure, because the door isn't going to open immediately, let's add 2 events. So first, we'll take the ray animation trigger and make it that activated color. And then we will also take our right door open timeline and animate it, playable director play. If I go back and look at the object that was gaze interactable, which includes the soda can. So let's go over here, gaze interactable object. Its layer is gaze interaction. So we need to make sure that it is on the same layer. So I know it's a bit disorganized. This wasn't on the same layer we had with the simple interactable where you go down here and choose the layer mask. It's the actual layer. So I will put it on gaze interaction for the layer of the object on the top right. Try it again. As with any software development, there are some bugs that you have to learn how to fix. Hopefully help you with a lot of that. But now it works because we forgot to put it on the correct layer. And then when I look at it for 3 seconds, it'll open the door. So maybe you have some kind of escape room and the user may have to grab objects, put objects in certain places, look at it, objects, etc. There's a wide variety of things you can do to trigger these animations. And that concludes this chapter. This one was a bit more brief than the last 2. Fortunately, because those were very, very heavy with the material. The chapters should be a bit shorter than those from now on. So we pretty much learned how to create animations, creating timelines as well, and setting up keyframes, and also how to trigger these animations with those interactable events using our XR manager. We also talked a bit about importing prefabs and editing those. So with that, that'll end this lesson, and next time we'll go over producing lighting for our scenes.